Hey everybody, Mr. Fortin here. Now I was grading homework recently. I had this problem here, 250, and I was checking it out. And this was involving solving equations, and I was seeing maybe a few more mistakes than usual. So, anyways, I figured I'd film this video, give you guys some tips, go through problems C and D, right? More mistakes on those, and get you some practice. Now I know that solving isn't going to be a major thing until chapter 3. That's our big solving chapter. But should you be familiar with problems like these a little bit? Well, yeah, they've come up on quite a bit of homework, so I'm giving you little tips along the way. And in general, you've practiced a little bit of solving kind of in middle school. So follow this video, follow some tips here. I'm going to give you these tips up here. Previously, in my previous solving videos, I would really just give you 2 tips, kind of these bottom ones here. But I noticed that this top one has this other thing here, this other idea of combining like terms. The 48 and 23 can get added to one another because they are something called like terms. They're not an x term. This is an x term right here because I see 8x. Okay, so 8x is different than 48, different than 23, but 48 and 23, those are just numbers. I can add numbers together. That's good here, okay? So combine like terms, collecting variables the same side of equals. We'll have to worry about that on this one here because I have x on the left side, I have x on the right side, I also have x again on the right side, so we'll have to combine like terms there too. And finally, we'll solve by doing the opposite, okay? Remember, solving doesn't involve, following PEMDAS and plugging in and getting something. Solving means undoing that freaking equation and figuring out how we can get x by itself here. How we can get x by itself there. So we need to kind of undo the whole thing. Doing the opposite is what cancels the operations happening to x. So we'll go through that third. Okay, part C. Let's check out part C here. We got to get x, right? X is right here. First step is something called combining like terms. Okay, combining like terms. We want to combine on the same side of equals. We just want to simplify our lives. This is 48, and we add 8x to it, and then we add 23 to it, it magically becomes 7, okay? Because that's what the equation is given to us. We have an equal sign here, okay? So if we're adding 48 to 8x, and we're also adding 23 to 8x, what are we really adding to 8x here, okay? That's why we want to combine like terms, okay? We want to combine like terms here. So when I do this little symbol, it means usually I'm either pulling something down or I'm combining like terms here. This is simply, there's something called the commutative property of addition, where if you're only adding things, order doesn't matter. So what this equation here, the way it's written here, this is really just the same thing as 48 plus 23 plus 8x here on the left side, and that's equal to 7. Okay, so what we can do here is we can actually do that. We can do 48 plus 23, and that combines these like terms, okay? These are like terms because these are just numbers. They're called constants, and numbers add to other numbers, right? Constants add to other constants. Variable expressions add to like terms, right? So if I had another thing with x's here, I could add it to that thing with x's, and I'd have a certain number of x's here, okay? Anyways, I hope you get the idea of what you need to do. You simply just need to add 48 plus 23, and that would give you 71, okay? Always have your calculator out, right? Have your calculator in class here because you want to move through the easy stuff like that quickly, and then you can make decisions right along the way, okay? I'm pulling my 8x down. There are no other x's here on the left side, so I just have 8x's on my left side. There are no terms, x terms to combine here, okay? That's equal to 7. Now I got 71 plus 8x. That's what's going to bring me up to 7. Okay, so I already know that x has got to be negative here, right? Because if I'm adding 71 to this, that gets me to a positive 7. That's not very big. It's going to be negative, okay? So the idea of this is going to be negative. I got to get rid of this 71 that's getting added to the 8x. What gets rid of addition? What's the opposite of addition? That's right, subtraction is the opposite of addition. So I'm going to subtract 71 here. And remember, if I'm taking away 71 from one side, it's going to make the side lighter by 71 units. And I got to preserve my equality, right? I started with an equal equation, 71 plus 8x equals 7. I take away 71 here. I got to take away 71 from the other side to keep my equation balanced. That's what I'll do. So remember, we do the opposite. We got to do it to both sides. So we can actually cancel this out, and then I'm left with 8x equaling, okay, this is 7 above 0. We got to bring out 71, okay? So I'm going to take 7 of the 71 taken away brings me to 0. And what's 7 less than 71? 64, okay? So this is going to bring me down to negative 64. I saw some subtraction errors on that on the homework here too. So have a calculator out. The best thing for you to do is to second guess your calculator. That allows you to go a little bit faster. Rather than just doing everything in your head real quick, type it out on the calculator and be like, wait, is the calculator right? Yes, and here's why, okay? So you're both doing the mental math and the calculator. Do the calculator first, and then double check your answers, okay? Now I got 8 times by x is equal to negative 64. Remember, if we don't see an operation there, that just means this is 8. This is x 8 times, right? We have 8 times x here, okay? What undoes multiplication, right? What's the opposite of multiplication? Opposite of multiplication is division, so I'm simply going to divide both sides by 8. Okay, 8 goes into 64. That one should be one you have memorized. You should really have the multiplication table memorized, 0 through 10, right? So this is 8 times 8 brings you to 64. 8 squared is 64, okay? So anyways, we divide both sides by 8. I have 8 x's, I divide by 8. Well, that leaves me with 1x, right? I have 8 pizzas, and I divided 8 ways. That's just one pizza. Split 8 ways right there here. So anyways, 8 divided by 8 is 1, and that just leaves me the x. I bring that down. Then I get 64 divided by 8 is 8, but I got to remember to bring down that negative, okay? And x here is negative 8, and we got our answer. How can I be sure my answer is right? I can plug back in, right? That's my solution here. Negative 8 should be the number that makes this equation true. So I put 8 here, plug in negative 8 for x, plus 23, and I'm going to just prove to you that my answer has to be right. So when it says check your answers, lots of actually check here, but you might as well check to make sure you got it right, especially if you're on a test, which we have a test coming up on Thursday. Okay, 48 plus 8 times by negative 8. Well, remember that was negative 64. Okay, and 48 minus 64 is what? Mental math, right? We have calculators out that we have here. Here, I'm gonna show you that's gonna be 7 here using my calculator. Okay, double check here. Make sure you got the right answer. 48 minus 64. Here, this is what I'm doing here. I'm just double check, plugged in 8 for x, and then add 23 to this, and I get yes, 7 here. Okay, and since that's returned to 7 for me, this whole thing here equals 7. And right side was 7 already. I know that whatever I plugged in for 8 must have made the equation true. And there it is. My answer, x is negative 8. It's correct. Yes. It's as if I teach math or something. All right. Okay. Anyways. All right. We got to do this one here. Okay. So this one's kind of a similar problem. Okay. Here's your little checklist. Combine like terms on the same side of equals. 2, collect variables. We're going to do that on this one to the same side of equals. And finally, solve by doing the opposite. Start away from the variable. Here, right, we got rid of the plus 71 first because that's further away from the x. 8 is touching the x, so let's wait until the very last thing. Just divide both sides by 8, okay? All right, combine like terms. Okay, what do we got here? 6x and 21. Can we combine those? Okay, this is an x term. This is called a constant term, right? We see, technically it's x to the 0th power, but anyways, we haven't done 0 exponents here. Coming up in chapter 3. Okay, so here there's nothing on the left side for me to combine because I have this term that's 6 times by x, and then you can't just take 21 away from that because can't take 21 x's away, right? It's just taking 21 ones away. This is the only ones we have, our constant that we have here. Okay, here the 17. Do we have any other constants on the right side here? 17 just like normal numbers that we're used to looking like since we started studying math? No, we don't. But we have a 5x and we have an x over here. Okay, remember, if we don't see a coefficient in front of this, coefficient is the number that's getting multiplied to the variable. What is the invisible coefficient? When we see x, we see it one time. Right? There it is. My coefficient of this is 1. No reason to show it. Just show plus x. This means plus 1x, okay? So if I combine like terms here, right? 5x and x are a like term. They're an x term. So I do 5x plus x. That gives me 6x. And then I got plus 17 over here. And now I've taken care of the first thing. I've combined like terms, okay? Next thing on my step list, my list of things to do, solving best equations best practices, is to collect a variable to the same side of equals, okay? So here, we're going to get an interesting result in this one here, I believe. Okay, collecting variables. I usually say subtract the variables where you have less of them on one side or get rid of the ones that have less than, because then you end up with a positive amount on the other side. Here I have 6x, here I have 6x. Those equal each other, so when I subtract that from both sides, something funky happens, something weird happens here. I subtract 6x from both sides. That goes away. That goes away. Wait, I've eliminated the variable I'm trying to solve for. What the heck? Oh, that's crazy. Okay, so I end up with negative 21, and that equals 17. And is that actually true? Is that actually true? Does negative 21 equal 17? No, it doesn't. No, it doesn't here. Okay, so here our solution set is no numbers, right? No numbers. No real numbers are solutions for this equation here. So what we can just write is no solution. There's no solution to this problem because there's no value of x that when we plug in wherever we see our x's here, right? We plug in 5 here, 5 here, 5 here. This left side, it's going to be a lot smaller than the right side. Negative 21 is a lot smaller than 17, right? So the left side is actually 38 lower than the right side here, right? If we combine like terms, we notice, we had the same amount of x's. Our answer is going to be no solution, or it might be all real numbers, okay? If our numbers actually equal to each other, our answers will be all real numbers. Anyways, that'll get reviewed in chapter 3. Okay, hopefully if you're struggling with solving a little bit here, you picked up something from this video, okay? Message me if you have any questions. coming up chapter 3, let's really start nailing the solving stuff. Thanks for watching, guys. Bye.